Boom. Inside this box is a new piece of technology that could completely redefine how the world connects. Bold claims, I know, but I'll put my name on it. I believe tech like this represents the future of wireless communication. Not to mention, it might be one of the most impressive builds I've ever shown on this channel. This is definitely something you've never seen before. I've waited over a year to get my hands on it, and no, you don't need 20 grand to own one of these, which kind of confirms what we've suspected all along about the military-industrial complex. But let's stay on topic, because this video isn't really about this device or even technology. It's actually about something much bigger. Freedom. The freedom to communicate and connect without being at the mercy of centralized providers that want to charge us a monthly fee for the rest of our lives. That's what Zero Trust Mesh Networks promise. Systems that are cryptographically sound, open, and unstoppable. They don't rely on the centralized powers that be, instead only math. And we're already seeing the world move in that direction. Back in August, Jack Dorsey dropped a weekend project that turned an iPhone's Bluetooth chip into a peer-to-peer messenger. And I immediately recognized what that could mean, and so I made a video about it. Then just a few weeks ago during Nepal's civil unrest, that app was used to organize when the internet went dark. And you may have picked up on it, but right now, a lot of the world seems to be heading in a certain direction. Right now, it's estimated that the UK now has 1 CCTV camera for every 12 people. People are literally being imprisoned for tweets. The EU and Australia are rolling out digital ID systems that tie into nearly every part of daily life. And you won't be able to opt out. It's being built as required infrastructure. Meanwhile, some of us here in the States, well, we've read 1984 and we don't need a live action remake. So if that kind of sovereignty is something that you care about, then decentralized blockchains, remote solar energy, 3D printing, and now mesh networking are technology concepts that can help us take the power from the few and put it into the hands of the many. And if you've been watching this channel for a while, you already know I'm all for that. All right, stepping off my soapbox now. Today, I'm putting this device through its paces, showing you exactly how it works, how you could set one up yourself, and what the net new utility it can give us actually is. Is this the future of communication, or am I just out here playing G.I. Joe? Only one way to find out. Okay, so what even is this thing? It's called a MANET, phonetically looks like MANET, which is short for Mobile Ad-Hoc Network. And basically, each device is a node in a mesh network and provides coverage and self-healing without the use of cell towers or centralized servers. And historically, it's been how the military stays connected in highly dynamic ops. But now, it's in my hands. Okay. So first up, we have an Ethernet cable. This is kind of a military spec, call it M12, with 4 pins on one side and a threaded screw so your connection doesn't get lost. We have a couple of antennas here. It looks like these are gonna be the sub-gigahertz antennas. And you can even see the kind of care and attention that these have been shrink wrapped at the connectors, which just gives it a little bit more durability and weather resistance. And we're gonna have our battery right here, which is a L3 Harris 12041 2400. We'll get to that in a little bit, but let's get to our actual device. I think that's everything. Okay. Wow. Wow. This thing has just a gorgeous sheen on it and just incredible design here. Yeah, I don't know. This thing has straight up sex appeal. All right, so let's get into the inner workings of this guy. So typically you want to connect any sort of sub-gigahertz antennas before you turn these on, because that radiation will be directed back at the board components and can damage them unless it has a proper outlet. So I'm just gonna throw these on for the sake of testing here. And then I'll show you real quick how you actually turn this thing on, and then we'll get into all the details. So let's grab this battery here. Now, the L3 Harris battery is kind of off the shelf. This is military grade. I believe they are used by the military. It uses this sort of flywheel connector. This is 7,000 milliamperes or 7.0 amp hours. Has pogo pin connector. Actually, on this side it has a flywheel twist connector, and then it has pogos, not pogos, but just plates here for a docking station. And what's pretty cool about this device is to turn it on, you come in perpendicular or at a right angle, and then you pull it in parallel, and you don't get any sort of indicator. Nothing beeps, no lights turn on, nothing spectacular, nothing to listen to. It's all solid state components, completely silent, but it's on. Which reminds me of this device here, which I went over about a year ago. People were kind of confounded by this. They were like, well, you know, you plug it in, you turn it on, but like, what does it actually do? It doesn't have any LEDs, it doesn't have any screen. How do you know what's going on? Well, what these both do is they're spinning up these sort of ephemeral wireless networks. And all you need to have are these devices within the vicinity of an end user device, such as, you know, an Android phone or an iPhone or a computer, Linux, any sort of computer really. And then this is where you do all the heavy lifting. This just supports the infrastructure and the network. So you just need this on your campsite, in your backpack, in your Humvee, whatever it is. And then you're using internet in the typical way that you would through IP networking and Wi-Fi 2.4 and a little bit of Bluetooth for something like this, and even Bluetooth for this if you're talking LoRa and Meshtastic and all that. But you're doing all your connection through your end user device, like your Android device, to do messaging, voice, video, whatever it is. This just supports the network, right? It's got the long range sub-gigahertz antennas. It has GPS. It has 2.4 MIMO local connection, and it has OpenWRT routing software to make that all work and to support several clients and to support things like mesh networking and what have you. All right, so let's get into the specifics of this thing. This particular unit was 3D printed privately using a PA6 CF20 material that combines nylon with carbon fiber to create a durable, temperature-resistant material, which should be pretty hardened. Now, this exact SKU isn't something you can just grab off the shelf. Trey, the guy behind Moro's X, does sell IP mesh radios and LoRa devices on his site, but these are prototype units built to order. If they catch your eye, I definitely reach out. He's one of the most knowledgeable builders in the space and hands down the best Fusion 360 designer I've seen when it comes to that off-grid mil-tech aesthetic. Trey also mentioned that he's testing some even newer materials that repel moisture and would give even more protection against the elements and a proper IP rating. We've got a heatsink plate on the front that when removed exposes some of the internals. A series of M3 screws varying in size. On the top here, we have a series of ports. The two front-facing SMA connectors are 2.4 gigahertz radio antennas, which support the local connection to any EUDs and provide MIMO data transmissions. The rear antennas are both sub-gigahertz, but each runs a different protocol in parallel. And in my opinion, any great piece of engineering needs that kind of built-in redundancy. One connects to the Wi-Fi HaLow chip, and the other to a rack 4630, which has our LoRa radio, which will be used to support things like Meshtastic and MeshCore. You'll also notice it has a ceramic active GPS antenna going into the rack board. But beneath the MCU is an off-the-shelf HaLow router board with an alpha card running a Morse Micro chip. The same chip we've used on the Haven build, just a different router board here. And the individual who reached out to me from the military mentioned that Alpha was a preferred supplier for these kinds of chips, so I'm hopeful they'll be able to perform in the field. Finally, we've got an upgraded M12 4-pin connector head for Ethernet, which feels like it belongs on a military satellite terminal. I'll probably be doing more with these kinds of mil-spec connectors in the future. And because this thing's a router at its core, direct network connections are crucial during the build and setup phases, and this connector makes that possible. Now, this This unit came with some solid stock antennas, but I've already started mixing and matching with other options. And antenna form factors and dBm signal ratings are a whole rabbit hole of their own, and that's something I'll be diving into in a future video. Okay, now let's get down to power, which is super unique. This connector here is called a flywheel or twist-locked pogo pin connector, which brings us to the battery itself. This is an L3 Harris 12041 2400. Now, this thing is full mil-spec, and it's actually kind of fun to read the certifications it has. It's rated for crazy things like thermal shock, solar radiation, chemical resistance, and rapid decompression at altitude, which tracks considering this thing isn't intended to sit around a boardroom. And because this thing is mil-spec, it also carries that price tag. Each one of these goes for about $320. So you might be wondering, where's the button on this thing? Well, this thing has no buttons, and to a layperson, you definitely wouldn't have any idea how to operate it, which is why it feels so futuristic. And to turn it on, we just power it by twisting the battery onto the device. You'll hear no boot sounds, see no LEDs, it's 100% silent with its fully solid-state architecture. So how do you use it then? Well, you don't click anything, and you definitely don't talk to it. This is an IP mesh radio. What happens now is we have a local Wi-Fi network available to any of our end user devices. As long as this thing is within a couple hundred feet of us, we'll connect over traditional 2.4 gigahertz to our end user devices running Android, iPhones, or whatever kit you might have. But that just sounds like Wi-Fi with a battery. So what makes this different? Well, it actually has multiple radios, each with special properties and roles. We've got Bluetooth low energy, which is ultra low power at about 10 milliwatts, around 125 kilobits per second, and works best within 10 meters. This is good for things like managing your LoRa board via Meshtastic or MeshCore. Then we've got traditional Wi-Fi, 2.4 gigahertz, roughly 100 megabits per second, draws about 500 milliwatts, and stays solid within 100 meters. This will be our fast link for connecting any end user devices within the local vicinity of our MANET. LoRa handles the long haul, about 5 kilobits per second, think GPS coordinates and text messages, draws under 100 milliwatts, and people say it can stretch several kilometers with line of sight. But I actually believe that the only thing stopping LoRa signals is the curvature of the Earth. I mean, the Earth may be flat, but LoRa doesn't think so. And actually last weekend, I put a LoRa node on a kite, and not even at full altitude, I picked up a node 15 miles away. And I have a hunch you could pull a signal from a satellite if unobstructed, but more to come on that. And finally, Wi-Fi HaLow, which is what I'm most excited about. It hits around 10 megabits per second, draws roughly 200 milliwatts, and is reliable for 1 kilometer or more. This is real internet at distance. Now, the physics behind LoRa and HaLow are pretty similar, but they function very differently, and having both long-range radio set decks running in parallel gives solid redundancy if one network fails. But something I'm really excited about and just started digging into is an open source project called Reticulum. It's a hardware agnostic communication stack that provides end-to-end encryption and mesh networking over pretty much anything that can push ones and zeros. In short, it doesn't care what hardware you're using. LoRa, Wi-Fi, Ethernet, serial, it just moves data securely across all of them. Some people are even using it as a control channel for publishing content over IPFS. It's a deep rabbit hole, but I've got a full video coming soon on how Reticulum could become the backbone for off-grid communication. And that's where this starts to get really interesting, because once you've got radios like this talking over long distances, you start realizing just how many real-world problems this kind of mesh can solve. On a farm, this same mesh could link autonomous tractors, drones, and sensors across hundreds of acres, all talking over open radios instead of a closed corporate network. Out in the wild, hikers and hunters could use it to stay connected several miles without cell service. Airsofters could run live maps and team comms across a field. Water sports crews could track boats and boards along a shoreline. And off-grid coordination groups from community responders to explorers could share position data, chat, and files without ever touching the internet. Before we get too too deep into testing, let's zoom out, because this isn't the first time someone's tried to decentralize connectivity. Helium promised a people's network, a decentralized wireless revolution powered by the community. Thousands bought in, deployed hotspots, filled maps with coverage, but the tech stack is still a black box, at the mercy of middlemen, and the payouts are just weak. Meanwhile, the military's been doing mesh for decades. Companies like Silvus, which Motorola just bought back in May for over $4 billion, and Persistent with their MPU-5 radios have been linking entire battlefields for years. But most of that gear requires special licensing, and as much as I like filling out forms and chatting with sales reps just to get a price for a product, that lack of transparency usually means it's not cheap. Then there's consumer routers from companies like Ubiquiti, which I personally use in my home, but the ecosystem is proprietary, and the moment you mod that firmware, you're voiding the warranties. And now we're seeing big players circling. Jack Dorsey with BitChat, Coinbase literally filed to trademark the word mesh, and Morse Micro, the company behind the Halo chip in most of these builds, just a few weeks ago raised $88 million to help them scale. So yeah, I may sound like a hype man sometimes, but there's clearly something real happening here. Everyone's waking up to what we've known for years. Mesh isn't niche. It's the future of connectivity. Now, this device sits right in the middle. Open, portable, inexpensive. And I'm not saying I'd want our comrades in contested spaces running one of these, but for those of us not going head to head with a nation state, this civvy version is the best game in town. Because most military radios require special licensing and certified infrastructure. This device can be owned and operated by anyone here in the United States. No, it won't give you turnkey jamming defense, Type 1 government crypto, or a FIPS certification. It won't magically provide enterprise WAN acceleration or black magic tricks like TCP spoofing. What you do get is the toolbox to build around those gaps. Resilient radios, MIMO, multiband protocol, WPA3 SAE encrypted comms on a fully open tech stack that you actually own end to end. And if you're willing to roll up your sleeves, there's nothing stopping you from going further than me and doing something completely new with this tech. And for anyone overseas, the UK, EU, Canada, or Australia, I reached out to Morse Micro about regional frequency support. They told me their upcoming MM8108 chip includes a built-in 26 dBn power amp. It basically gives us a single piece of hardware that's flexible enough for global use. The chip's not out yet, but it's coming soon. So if you are outside the US, just hang tight. This tech is what happens when the power of a $20,000 military radio finally lands in your backpack. And that's what this channel is really about. Bringing a parallel tech stack online, open source, affordable, and capable. No middlemen, no centralization, and no monthly subscriptions. Just tech you can repair, upgrade, and keep out of the landfill. So that's the landscape. Let's take it outside and see what it can really do. So for this example, you need 2 Halo nodes. So for my roaming client, I'll use the Moros X radio, but for my base station node, I'll use the Haven build that I've talked about before. And for anyone interested in building one of these on the cheap, the OpenMANET project on GitHub is probably the best way to go. I'll leave my guide for the Haven build in the description below. And OpenMANET is an open source project based on Morse Micro and OpenWRT that uses very inexpensive chips like this Halo card from Seed Studio and layers in 802.11s mesh and an increased transmit power to create a modular open source MANET. And OpenMANET also has a case if you do end up building one of these. And there's a ton of activity around this idea right now, so I'm hopeful we'll get more options when it comes to protecting our gear. Now, where the Moros X mesh node deviates from the Haven is in a few places. First off, it's hardened like no other, and that goes without saying. But it also has a rack LoRa board with a GPS antenna in there, which brings us Meshtastic and mesh core support. It also has proper SMA antennas for 2.4 MIMO connections and a mil-spec Ethernet jack. But Haven has some advantages too. I've got to say that the Raspberry Pi builds seem to work better than at least this router board just in terms of configuring OpenWRT. It's probably because it's a beefier SBC than this board. On the back of OpenMANET, Haven also gets the increased transmit power bumped up to 27 dBm and 802.11s mesh with multicasting and Batman support. But honestly, both are solid and will likely get even better pretty quickly in future iterations. Okay, so this first test is a fun one. We're going to do voice over IP using Wi-Fi Direct. Okay, so we're running a speed test. I'm connected. This guy's connected on Wi-Fi 2.4 to the Moro's X IP mesh radio, and that's all connected to my Ubiquiti router. And you can see we get 7 up, 7 down, which makes sense because we're on the 4 megahertz channel. All right, I just want to give you guys a quick look at what I have going on with my actual Ubiquiti home network router. Basically, this guy here, the Haven Raspberry Pi 4 with the Seed Studio hat, is directly wired into my Ubiquiti router through Ethernet, and it's acting as an access point with a 9 sub-gigahertz antenna. So this just brings HALow to my router here. So now we could bring other HALow clients on, like the HALow IP mesh radios that I'm about to bring online, and those will be able to connect to my local network. They should have internet. It's all bridged, it's all routed, and everything's IP available. So if you ever get stuck with these things, you can always plug it directly into your router and then go to your router admin page, and it will always hand out an IP to this, and you can log in that way. All right, so we have our little test rig here. So this is the base node. It's running the gooseneck. Seems to have a pretty good signal right now. So I'm just gonna let sleeping dogs lie. And we're gonna go just through the hallway, go through some concrete, and see how the signal holds. Like right here, again, we're in the same room. So we're on the 4 megahertz channel. So the theoretical limit there is around 7 megabits per second. So you can see we're getting full signal pretty much. Just double check it. 7 down, 7 up. But now, we're gonna see what happens when we go through some walls here. So now you can see the signal is stretching. And we're gonna go through some concrete and metal, which always hampers signal because metal is essentially a Faraday cage. So we're gonna go up. So it's funny, we're actually 1 floor above my apartment now, and you can see the signal's coming back quite good. So it's funny. All right, so it's going through at least 1 floor, still getting good signal. For some reason, it doesn't like the stairwell. Let's see. Keep pushing it here. See, now we're 2 floors above my unit. Still getting a signal though. Okay, so we've done this test before. Basically what we got going on is we are connected to the MANET through a local 2.4 network, codenamed Spitfire. That is this guy. And if we want to surf the internet or run a speed test, we're getting a connection. But what's interesting is that internet is coming from way up there, because that's where my other MANET is with an uplink. And you can see, again, we're at the 4 megahertz channel width, so we're not going to get the 15 megabits per second, but we should get a max of like 7 megabits per second. You can see right now the signal is holding, so we're going to keep going further and see how far we can get a signal with. So this connection right here is coming from way up there. You can see we're just getting tons of distance here. And I'm actually going to go behind this building here, which is basically going to obscure our line of sight, but we should still be able to get a connection. So let's do that right now. Okay guys, we're like really far away from my apartment right now. We have at least one building directly obscuring our line of sight. And let's see what we can get for a speed test. Yeah, we still have a connection. It's crazy. You know, the data throughput's kind of low, but the fact that it's still getting a signal is just wild. Can you see me?
Yes.
Okay, so this right here, this connection, we're doing FaceTime here, is using Wi-Fi Direct because my phone has cellular turned off. And you can see Bluetooth's turned off. The only thing that's turned on is Wi-Fi, and it's running Spitfire. So you can see we're connected over the MANET radio and doing video over IP using Wi-Fi Direct, which is pretty cool. Okay, so I want to show you what I have set up here for a rig, and hopefully it makes sense in your mind. So we have our Starlink. So this is our uplink. This is a full dishy, and it has the Starlink router with it. So that's giving 2.4 local Wi-Fi. And then we have the Haven. We have the Haven MANET in there with the sub-gigahertz antenna. So this is a HALow-enabled Wi-Fi rig. Now, this would be our like base node, our base configuration, mission control, what have you. And then for the remote setup, we have this guy. This guy has 2.4, and it also has HALow and LoRa, but we're just going to use HALow right now. And I'm connecting to that guy with this right here. And you can see this has internet. If I do a speed test, so not crazy internet. I think we're on a 4 megahertz channel. I'm not sure exactly, but it has internet, has slow internet over Wi-Fi, over Wi-Fi HALow. So now we're going to see how far we can go and still get a signal. And just some tricks of the trade here. So like this computer's on the Starlink network, and we can log into the HALow interface here. So we can get some details and do management on the go. We can see we have that one connected device, which is the IP mesh radio. Signal's decent. So that's how you can manage that. Now, if you want to get fancy, for the other node, for the IP mesh radio node, the Moros X one, you can manage that if you make the Lucy portal available over Wi-Fi, which I did. So I can actually manage that all here. And let me just show you the network stuff, right? So this is connected to Spitfire. DS_SL is Data Slayer Starlink. And then Spitfire is the Moros X 2.4 Wi-Fi. And these two are bridged over HALow. That's the whole idea of this thing. So that is the gist of our setup here. So we can confirm what our exact HALow configuration is. So we're on the 4 megahertz channel, which doesn't have as much bandwidth, but it has better range. And we're operating at 926. I set it to 926 because I wanted to be a bit further away from LoRa, just to avoid potential interference. And LoRa is like high 800s to low 900s. So 926 is above what LoRa would be doing. So that was the idea there. And then you can see we have our SSID and all that stuff. So Okay, so anyways, that's the configuration for HaLow. Now let's go and test it. All right, so now we're getting a much better connection right here, but again, we're not very far from our base node. So we're gonna see how far we can take it. So very unironically, ended up at a military museum. It was not planned, but here we are, sporting 2025 military tech, 1940 military tech. All right, we got our Sherman over there. Still pulling a connection, and our base node is, I don't know if you can see it down there. Yeah, it's right over there. Can you wave? Okay, so now we're talking over a different app. This is WhatsApp on my Android phone. My Android phone has no cellular, no SIM card. It only has a local Wi-Fi connection to Spitfire, which is my MANET right here. And we are indeed chatting over WhatsApp. No special settings needed. You can hear me, babe, right?
Yes.
A little bit of latency. I don't know if that's the connection, but yeah, so we are able to chat. A little grainy, but I mean, this is pretty high data rate activity, and we're doing it over long range. We're doing it without cell towers, centralized servers. We're doing it just using these little sub-gigahertz antennas right here, and it gets you pretty far, so that's cool.
Connect.
Okay, so now we're gonna set up Meshtastic and send a couple messages. This should be pretty easy, but I just wanna prove out that this has a LoRa radio inside it as well. So basically what I wanna prove out right now is that we can do Meshtastic and HaLow simultaneously. So I'm actually connected to Amelia over WhatsApp, so that's HaLow, and then we're going to exchange some messages over Meshtastic at the same time. I just want to prove that there's no interference between those two communication stacks. Amelia, I'm going to send some messages.
Okay.
You done? Right. Good.
So sending LoRa messages, all while being connected over WhatsApp, WhatsApp video at the same time. So just proving that out. But all of this new functionality means nothing if the hardware can't take a hit. In my first MANET video, the Open MANET Haven build, a lot of you loved the tech, but you also pointed out the obvious. It looked fragile. Bare metal, no protection, just utility. This time, that changes. The Moros X is sealed, hardened, and built like a field device should be. It's still not indestructible. Nothing in this space is. Well, except maybe a Nokia, but it's a big step towards something you can actually trust in the field. So let's find out if it can actually handle what it's built for. Now, earlier I said this might be the coolest piece of tech I've ever covered on this channel, and that's exactly why what I'm about to do feels so wrong. But you guys asked for it, so here it goes. And we're still connected. For more killer tech, click here.